Predicting solubility in water. What we are going to work on is seeing if we can learn how to predict whether a compound will dissolve in water completely, or if we can predict a compound a solid will form in water, precipitate, and will it come out of solution. This is kind of a fun little project. Put a Twinkie in water, see if it will dissolve. Even after 2 days, it hasn't done much. But after 4 days, it looks like it's starting to dissolve a little bit, and it still tastes like a Twinkie. So those Twinkies are indestructible pretty much. I like this cartoon. One fish says to the other, "That killer virus, VHS, it's in our water." "Relax. There's enough prescription drugs that we'll be okay," says the other fish. And that actually is true. We did a research project where we tested what was the influent, the incoming water to our San Antonio sewage treatment plant, and the effluent, the water outgoing of our sewage treatment plant. And here's the chemicals that we found. These are chromatograms, and notice how they look very similar, especially these two peaks. And the effluent is cleaned up a little bit, but there's still a lot of compounds in there. And some of the drugs that we found, ibuprofen, right? You recognize that? Advil, and naproxen. So it's kind of, that stuff is in our influent and our effluent. This was a really neat gentleman. He's a chemist that works at the sewage treatment plant, and he actually drank the effluent. That's how confident he is in what the plant is putting out. I'm not so sure I'd want to do that, but. So what happens when an ionic solid dissolves in water? We may have seen this animation before, but that's okay. So recognize our ionic solid, and you recognize these molecules flying around, our water molecules. So we have the water molecules, right, floating around in our crystal, and notice the oxygens of the water molecule, they surround the sodium ions for this salt, right? It's hydrated sodium ion. And then the hydrogen ions will solvate a chloride anion. So this is what dissolving looks like. And not all compounds are going to do this, right? So this is what you would call a soluble solid. The water is just actually breaking it up into its constituent ions. Let's do a little review, writing ionic compound formulas and breaking them up. Here's a compound. Do you remember how to name it? K is potassium. This is phosphate. So potassium is in group 1, has a charge of +1. It's like all the elements, all the metals in group 1. Phosphate, you had to memorize that polyatomic anion, had a -3 charge. And remember, those charges just became subscripts. Okay? So then when we break it up into its ions, you'd actually have 3 potassium ions and 1 phosphate anion. And you can write the 1 or not. When an ionic compound dissolves in water and breaks up into its ions, then it is said to be soluble. When do you use these subscripts AQ or S? When a compound is soluble, then you're supposed to use AQ for aqueous. If it's insoluble, then you're supposed to use S for solid. Solubility rules. These are the rules that we're going to use to determine, to predict whether an ionic compound is going to be soluble or insoluble. So insoluble means that it won't dissolve. It will remain as a solid in solution, or it will form a solid in solution. So here we have a couple tables here. Just know this first one, right? All those formulas and names of the polyatomic ions. Know those. This table, just know how to use. Because I'll give it to you. I'll give you this table. Okay. So let's circle these compounds, circle all the ones that are going to be soluble. Okay? So we're going to use this table, and to get an idea how to use the table, notice how they're all anions. See, all these in the table, except for ammonium, pretty much everything is the anion. So let's just look at the anion. So this is calcium chloride. So we're really looking at this chloride anion and find it in the solubility rules table. And here it is. Okay, so it says that it's soluble. It says that chloride is soluble with everything except for, right, here's exceptions, except for these. So what is the chloride with? It's with the calcium ion. And calcium is not listed here. Calcium isn't listed there. So that means chloride is soluble. Chloride is soluble. Calcium chloride is soluble. So circle it. How about calcium hydroxide? See if you can find hydroxide. Here's hydroxide. It's supposed to be insoluble, but we should check the exceptions, right? What's the cation? Ca plus 2. There's exceptions, common exceptions. So that means that calcium hydroxide is soluble, right? Because most hydroxide compounds are insoluble, but not calcium hydroxide is an exception. Calcium sulfate. Okay, here's sulfate. The table says that they're all soluble, so we should circle it, but check the exceptions just to be safe. Calcium's not an exception, so that's definitely soluble. Lithium bromide. Bromide is soluble. Ammonium chloride. Now notice how ammonium is right here. There are no exceptions for ammonium. Lead iodide. Here's iodide. And iodide is always soluble except for lead. So that's going to be insoluble. That's going to be an S. It's going to be a solid. Okay, so that's pretty much how you use those rules. This is the handout that you're going to be using for exam 2. Water soluble. If so, write the ions that would be present in the water. Okay. Potassium nitrate. Nitrate, no exceptions, they're all soluble. So that's going to be AQ. Break it up into its ions then. Potassium and nitrate. So do that for all these and see if your answers will agree with mine. Lithium carbonate. Lithium carbonate. So here's carbonate that are all insoluble except for the alkali metal cations. And guess what? Lithium, here's the alkali metals. So lithium, sodium, potassium, that are all the alkali metals. So they never form precipitates with anything. So aqueous. So we're going to have 2 lithium ions and a carbonate anion. Iron acetate. Here's acetate. It's always soluble, no exceptions. If you're not sure of these charges, use the subscripts. Use the trick. And we have 2 of those acetates. Right, here's a 2, so that means it has to be iron plus 2. And that's a 1, so acetate must have a -1 charge. Lead chloride. Chloride is soluble, except for lead, solid. Lithium iodide. Iodide is soluble, especially with those alkali metals. Magnesium bromide, soluble. Magnesium's not an exception. So magnesium ion and and 2 bromide anions. Copper 2 chloride. Chlorides are soluble, aqueous. Copper 2 and 2 chloride anions. Sodium sulfate. Remember, all those alkali metals are always soluble. So I'm not even going to look at the rules. 2 sodium ions and a sulfate anion. Silver sulfate. Sulfate is always soluble. Silver is not an exception. Aqueous. We'll have silver ions, 2 of them, right? See, there's 2 of them, and 1 sulfate anion. Iron 3 carbonate. Iron 3 carbonate, always insoluble, except for it's not an exception, so. Ammonium sulfide. Ammonium is always soluble, according to the rules. So 2 ammonium ions and a sulfide anion. Magnesium oxide. That should be listed right here. And it's missing. So they're insoluble, and magnesium is not an exception, so that's going to stay as a solid. Lithium oxide, well, alkali metal, it's an exception. AQ. So I'll have 2 lithium ions and an oxide anion. Barium oxide. Oxides are insoluble, but barium's an exception. So I get a barium ion and an oxide anion. Chromium 3 hydroxide. Hydroxides are insoluble. Chromium is not an exception. So solid. Insoluble. Aqueous solutions of calcium chloride and lead 2 nitrate are mixed. Write the balanced molecular, ionic, and net ionic equations. So it's easiest just to show you how to do this. So molecular just means no ions. So we write our 2 reactants together. And they said it was calcium chloride. Calcium chloride. You realize calcium is in group 2, right? All of these have a charge of +2. So calcium has a +2. Chloride is a halogen. It's 1 away from the nobles, so all these have a -1 charge. So CaCl2 is calcium chloride. And lead 2 nitrate. Lead 2, and remember nitrate? Put polyatomics in parentheses, it's easier. I have a 2 down there. Okay, so our game plan here is to combine this cation with that anion and this cation with that anion and see if we can get a precipitate. That's going to look like calcium ion with the nitrate anion and the lead ion with the chloride anion. Now I put those charges in because it helps me, because then I know how to make the subscripts. I need a 2 here, and I need a 2 there. Okay? Now let's make sure we're balanced. I need 2 chlorides on both sides, 2 nitrates. Looks great. Looks nice and balanced. The next step is to put AQ or S on every compound, aqueous or solid. So calcium chloride, aqueous. Lead nitrate, aqueous. Calcium nitrate, aqueous. Lead 2 chloride, solid. So we will be getting a precipitate. Make sure that you're balanced. Looks like we have a balanced chemical equation. So the ionic equation, wherever we wrote aqueous, AQ, we're going to break it up into its ions. If you have a solid or a liquid, you don't break it up. So wherever you have AQ, break it up into its ions. So I'll have a calcium ion and 2 chloride anions, a lead ion, lead 2, 2 nitrates. On the product side, I'm going to have a calcium ion, 2 nitrates, and then my lead 2 chloride does not have AQ on it, so I have to write solid. Now for the net ionic, what you do is you cancel what you can. I can cancel calciums, I can cancel 2 nitrates, so all I'm left with is 2 chloride anions, lead 2 forms lead 2 chloride. So that's the game plan. Let's try it again. Write balanced molecular, ionic, and net ionic chemical equations when the following solutions are mixed. Sodium sulfate and barium nitrate. Sodium sulfate and barium nitrate. Barium is in group 2. Okay, let's fix our charges. Make your charges subscripts. Okay. So what could they form? So remember the game plan for this. Combine this cation with this anion. Combine this cation with this anion. So we'll have sodium ion combined with the nitrate anion, and we'll have the barium ion combined with the sulfate anion. Okay, make your charges subscripts. Here they're just going to cancel out. Okay, make sure you're balanced before you move on. You have 2 nitrates on this side, so we have to have a 2 here. And see, we're balanced now. Okay, now remember the next step is to write AQ or solid on everything. So alkali metals, always AQ, sodium ion. Nitrates, always AQ. Alkali metals, always AQ. The only possibility here is barium sulfate. Sulfate are all soluble, but barium's an exception. Solid. So there's my molecular equation. So let's write the ionic equation now. And remember the idea for that is just if you see AQ, break it up. Otherwise, leave it alone. 2 sodium ions, a sulfate anion, a barium ion, and 2 nitrates. Product side, 2 sodium ions, right? Because I have 2 of these guys. So I have 2 sodium ions and 2 nitrates, because 2 sodium nitrates are breaking up. And then the barium sulfate, but keep those ions together because it's a solid. The net ionic, cancel what you can. Sodium ions, 2 nitrates. So I'm left with sulfate and a barium ion. Form barium sulfate solid for my net ionic equation. Magnesium sulfate and potassium iodide. So magnesium is in group 2, so it has a +2. Sulfate has a -2. So those 2's just cancel out. Potassium is in group 1. Iodide has a -1 charge. So what are my possibilities here? I can form magnesium with the iodide and potassium ion with the sulfate. Okay, make your charges subscripts. Okay, Make sure you're balanced. I have 2 iodides here, so I better put a 2 in front. I have 2 potassiums. Okay. So there is my molecular equation. Oh, I'm not done. I have to write solid or AQ on everything. Magnesium sulfate. Sulfate is AQ. Potassium, definitely AQ. Magnesium iodide. AQ. Iodide compounds are AQ. Potassium, AQ. So there's my molecular equation. Everything is AQ. So in my ionic equation, I have to break everything up. Magnesium and sulfate and 2 potassium ions and 2 iodide anions, a magnesium ion, and 2 iodide anions, 2 potassium ions, and a sulfate anion. Now you see what's going to happen for the net ionic equation? Everything cancels out because everything was soluble. There's nothing left. No reaction. So when everything is AQ, you pretty much just write no reaction. You're done. Lead 2 nitrate. So I have a lead 2 and a nitrate. So that 2 had better be a subscript. I have potassium hydroxide. Potassium is a plus charge. Hydroxide is a negative charge. So what are my possibilities here? I can combine the lead 2 with the hydroxide anion and combine the potassium cation with the nitrate anion. Make my charges subscripts. Okay. Now let's make sure you're balanced. Don't forget to do that. I need 2 hydroxides on both sides. I need 2 nitrates on both sides. Okay, that looks balanced. So that would be my molecular equation. Oh, I have to do AQ and S, right? Nitrates are always AQ. Alkali metals, always AQ. Lead 2 hydroxide. Hydroxides are insoluble, and lead's not an exception. So there's my solid. Alkali metal, AQ. So the ionic, break everything up that has AQ. I have a lead ion, 2 nitrates, 2 potassium ions, 2 hydroxide anions. Keep the lead 2 hydroxide together. That's a solid. 2 potassium ions and 2 nitrates. My net, cancel what you can. The 2 nitrates, the potassium ions. So I end up with lead 2 plus 2 hydroxide anions forms lead 2 hydroxide. Let's try this one. Zinc chloride and sodium sulfide. This is kind of a tricky one. See if you remember this. Zinc had a plus 2 charge. Remember that? Chloride is 1 away from the nobles, so it's only -1. So the 2 has to go down there. Plus sodium. Sodium's in group 1. Sulfide, 2 away from the noble gases, so -2. So the 2 has to go down there. All right, what could it produce? I'll combine the zinc ion with the sulfide anion, and I'll combine the sodium ion with the chloride anion. Let's make your charges subscripts so everything looks okay. We need to balance it. I've got 2 chlorides here, so I need a 2 over here. Now I have 2 sodiums, 2 sodiums. It looks good. So there is my molecular equation. Once I put AQ and S on everything. Zinc chloride. Chlorides are soluble. Zinc's not an exception. AQ. Sodium sulfide, alkali metals, always AQ. Zinc sulfide, solid. Alkali metal. Ionic, break up everything that is AQ. So that's zinc ion and 2 chloride anions, 2 sodium ions, sulfide anion, zinc sulfide solid, and 2 sodium ions, 2 chloride anions. Okay, let's cancel what we can to write the ionic. Sodium ions and my chloride anions. So I'm left with zinc, and sulfide forms zinc sulfide solid. Potassium carbonate. Potassium is in group 1. Carbonate is CO3 negative 2, so my 2 has to go down there. Plus ammonium. Ammonium is NH4 plus. Chloride is Cl minus. What can it form? Potassium with the chloride and the ammonium with the carbonate. So that 2 has to go down there. Let's make sure we're balanced. I need 2 ammoniums, so I better put a 2 here. I need 2 potassiums. Now I need 2 chlorides. We're good to go. So molecular. That's right, solid or AQ on everything. Alkali metals are AQ. Ammonium is always AQ. Alkali metals, always AQ. Ammonium, always AQ. So no reaction. Sodium hydroxide and magnesium chloride. Magnesium is in group 2, so that's a +2. Chloride is -1, so 2 has to go down there. What could it form? Combine the sodium ion, the chloride anion, and combine the magnesium ion with the hydroxide anion. Charges become subscripts. So now let's determine if everything is aqueous or solid. Alkali metal, always aqueous. Magnesium chloride, aqueous. Alkali metal, magnesium hydroxide. Hydroxides are insoluble, and magnesium is not an exception. So my ionic, for my balance though, I need 2 hydroxides, so I better put a 2 here. 2 chlorides, I need 2 sodium ions, we're good. So break up everything that's aqueous. So I'll have 2 sodium ions and 2 hydroxides and a magnesium ion, 2 chloride anions, 2 sodium ions, 2 chloride anions, and magnesium hydroxide solid. Cancel what you can. Sodium canceled. Chloride. So my net, I'll have 2 hydroxides and a magnesium ion forms magnesium hydroxide solid. Okay, so the name of the game here is pretty much know how to use these rules. And I think it's really helpful to know that whenever you have an alkali metal, it's always aqueous. Whenever you have the ammonium polyatomic ion, it's always aqueous. To get the charges, these are always +2, +1, and you count over to the nobles for these anions. -1, -2, -3. Okay, good luck.